Converting number base types is an important part of learning computer science. This allows us to manipulate information so we can have the computer perform different functions depending on what the computer requires. Right now, you are used to base 10 math. So this is what we are used to. This simply means that after the number 9, next comes 10, 1 and 0. So base 10. I'm going to show you how you can convert to any base today. However, the two most important ones that we'll talk about are binary, which is the very lowest level of number conversion that we will use in computers. This is the infamous 0 and 1s that you hear about that processor chips use, which I have an additional video to show you with that one, or with that to explain how binary is used in the processing chips more. The other one we're going to talk about a lot is the hexadecimal, which is a base 16. And this is what is used to make color combinations most often. If you've ever worked with web design, the different color codes, that was a 6-digit code, was compiled of the hexadecimal system, which we'll talk about a little bit later on in the next slide. Real quickly, here is an example of a hex code chart that would be used for web design for finding different colors. These are not all the color options, however, these are some of the main colors, and you're going to understand how those F's, C's, the different letters you see in there play into this real shortly. So how do bases work? Well, it's actually really simple. Whatever the base number is, every number that we're used to below, and I'm talking about numbers below base 10 here, are an option. So, for example, if I have base 2, which is again our binary, the only numbers I can have as a result are 0 and 1. For a base 3, I can have 0, 1, and 2. Base 4, 0, 1, 2, and 3. Right down the line all the way to base 10. Here is the completed chart. Now, keep in mind, we're talking about if we're converting from a base 10 to another number. So let's take a look at what we notice in a pattern here. If I'm looking here at the 2, I notice that 0 and 1 are both less than 2. And same with 3, 0, 1, and 2. And all the way down to even 10, you got the 0 and the 9. So what this is actually telling me is we're solving for something particular when we're trying to find these different numbers. We're solving for something that may not be part of the whole number. This is simply using our remainder math that we've practiced so much with integers. That's all base conversion is taking the remainders and putting them in a certain order. The biggest trick with this is that when we're building the numbers for the final answer, we're actually working backwards, which I'm going to show you as an example here on this next slide. So here's an example. Let's take the number 11 and we're going to convert it into binary. So I am going to take 11 and divide it by 2. So whole number wise, I know it's going to be 5, and I have a remainder of 1. So I'm going to put that 1 at the end of my binary number. Then I take the 5 that I just solved for, and I divide that by 2. And that becomes 2 remainder 1. So there's another 1. So now I am going to take 2, divide it by 2. And it's a 1 with a remainder of 0. So I put the 0 there. Then 1 divided by 2 is 0 with a remainder of 1. So 11 in binary, so 11 base 10 is equal to 1011 in base 2. And you will see the application for this when we're talking about the different switches on the following video. Okay, now it's your turn to try it out. Go ahead and grab a sheet of paper and a pen real quick, and you are to solve these 3 problems doing the exact same thing I demonstrated on the previous slide. I will then show you real quickly the math for each one. So let me give you a clue. You see how these other 2, the second and third one, have different base numbers? Instead of dividing by 2, you would divide by 5 and 8. So it all depends on the base as to what you're dividing by. It's that simple. Go ahead and give them a shot. You are to pause the video right now. How'd you do? Well, let's find out. I'm going to take 15, divide it by 2. So it comes out 7 with a remainder of 1. So 1 will be there. 7 divided by 2 is 3 for a remainder of 1. 3, 2. So 1 goes there. 2 divided by 3 equals 1, I should say, with a remainder of 1. There's another 1. 1 divided by 2 is 0 with a remainder of 1. So 4 1s is the correct answer. For 15 with a base 10 going to base 2. So 1 1 1 4 1s and the 2. Base 5, all we're doing is we're just changing it up a little bit. So 29 divided by 5 is 5 with a remainder of 4. So the 4 goes to the back. 5 divided by 5 is 1 with a remainder of 0. So we have the 0, and 1 divided by 5 is 0 with a remainder of 1. So your base 5 number should come out to be 104 to the base 5. And then finally, my 17 and base 10 converted to base 8. 17 divided by 8 is 2 with a remainder of 1. Put the 1 on the end. 2 divided by 8 is 0 with a remainder of 2. So the answer there should simply be 2 1. Once you get the hang of simply putting your remainders in reverse order as you are solving them, it really is pretty simple. Again, this applies to all numbers lower than a base 10 as far in regards to what base they are in. I'm going to show you next what happens when it's higher than base 10.